Hello guys, and welcome to lesson 1E. I can use the segment addition and angle addition postulates to write algebraic equations to find missing values in geometric problems. So first we're going to talk about distance and length. Well, the distance between 2 points is the length of the shortest segment that connects those points. The distance between 2 points on a number line is the absolute value of the difference of their coordinates. And so why are we using absolute value? Well, when you're driving in a car and somebody asks you how far away are you from a place, you always answer a positive number. You never say, well, I'm negative 4 miles away. You say, I'm 4 miles away. So distance is always positive. So that is why we use an absolute value to figure out distances, because we need our answer to always be positive. So let's look at this on a number line. For example, UV on this number line here, U is at 10, V is at 14. That has clearly a distance of 4 units between them. I would never say negative 4 units. It's just plain old 4 units, no matter which way we're going. So if I wanted to find distance between S and T, and I couldn't count or wasn't going to count or had horrible numbers, I would say that ST's distance is equal to the absolute value of the difference of their coordinates. Negative 4 minus 8, which is the absolute value of negative 12, or plain old 12. So ST's distance is 12. All right, guys, I want y'all now to take a moment and find the distance of those remaining 4 segments. Go ahead and pause your computers and do that right now. So what I want you guys to pay special attention here is VS and SV. Those are the same segment, but going in 2 different directions, traveling from S to V or from V to S. Notice the distance does not change. The order in which you list your endpoints doesn't matter because distance is always positive. All right, now let's talk about the segment addition postulate. And it's one of those kind of no-duh sorts of postulates, but let's talk through and talk about why. If points A, B, and C are collinear, where B lies in between A and C, then AB plus BC equals AC. Well, I don't know about you guys, but that was a whole lot of letters. I need a picture to know what on earth they're talking about. So let's draw it. A, B, and C are collinear with A between B and C. So I've got 3 points where B, that's a B, is between A and C. And they say that the length from A to B plus B to C equals A to C. That's a no-duh postulate. Basically saying that part plus part equals whole. So this is your big idea here, guys. Part plus part equals whole. So do my points have to be collinear for this to be true? Absolutely. What if I had A, B, and C? Well, the length from AB plus the length from BC would be longer than the length from AC. So that's why they have to be collinear. And furthermore, B has to be between A and C, because if I put B as my outer point here, right, B, AC, well, AB is this short segment, BC is this long segment, and then AC is another short segment. So that would be part plus whole equals part, which clearly doesn't work. So that's why we have to be told that B is between A and C. All right, let's take a look at some examples. I want to know the length of DW on this segment that has points D, F, and W. Well, if I'm looking at my part plus part equals whole, then I would say my first part is DF, my second part is FW, and my whole is DW. And let's now plug in. DF is 14, FW is 22, that's going to be equal to DW. Add those together, I get that 36 is the length of DW. So that's not too bad. My part plus part equals whole. And we can even use that to work backwards. Here I have a part of GB plus part BR, and together part plus part must equal the whole GR. So let's look at what they tell me. GB is 15, GR is 74, and I'm hunting for BR. So if I want to find BR, all I got to do is subtract the 15 over. So I end up getting that BR is in fact equal to 59 units. And that is my answer. So moving right along, just to summarize again, when we're talking about the segment addition postulate, it's always a part plus a part equals the whole. Part plus part equals whole. We then plug in the things that we do know, and we start solving for the variable. And once we have the variable, we can plug that variable back in to find missing segment lengths if required. So let's take a look here at this example. E is between P and S. So let's draw that, shall we? So we've got a little segment here where E is between P and S. Oh, look, PES. What a surprise. And they tell me that PE is equal to 4x plus 6. Notice I'm labeling my diagram as I go along. ES is 7x plus 15. And PS, that's this whole length here, is 120. So if I'm thinking about my part plus part equals whole, well, that's part is PE, other part is ES. That's equal to my whole of PS, or plugging in 4x plus 6 plus 7x plus 15 is equal to 120. Combine your like terms, I get 11x plus 21 equals 120, or 11x equals 99, so x equals 11. But they didn't want x, or just x, they also want the length of PE and PS. Well, PE is equal to 4x plus 6, or, oh, I made a mistake up here, friends. Did y'all notice that this isn't supposed to be 11? This is supposed to be 9. Yay. Paying attention for the win. Okay, so PE is equal to 4 times 9 plus 6, or 36 plus 6, so PE equals 42. All right, guys, I want y'all to take a moment now, and I want, rather than finding PS, I want you guys now to find ES on your own and tell me what it equals. So go ahead and do that now. All right, y'all should have gotten that ES is equal to 78. So hopefully you got that correct. Okay, let's now take a look down here. We say that segments with the same length are called congruent segments in geometry. So we've talked about congruence in the previous couple units, but we're going to keep talking about them now in terms of equal lengths. And we make matching markings on segments to indicate that they are congruent. So looking at this diagram down here for segment SA, it shows me that segment SF and segment FA are equal in length. So when I know that they're equal in length, that means they're equal to each other. So I could say that my SF, which is 3x minus 2, then that in fact is going to be equal to FA, which is 4x minus 9. And when I solve that, I bring my 3 over here, my 9 over here, I get that the x is actually equal to 7. And so now with that information, I can find all these missing things. Well, SF is equal to 3x minus 2, or if we're doing this, 3 times 7 minus 2, or 19. And FA, we already discovered, is equal to SF from our diagram, so it must also be equal to 19. All right, guys, I want y'all now to take a moment and find the length of SA and tell me what you get on Edpuzzle. You should have gotten that SA is 38 on Edpuzzle, so go ahead and check your work now, and if you don't understand, be sure to ask a question in class. All right, so we've talked about the segment addition and postulate. Well, there's also an angle addition postulate, and my angle addition postulate is still the same idea. It's still part plus part equals whole, just has a slightly more complicated diagram. So if B is a point in the interior of angle AOC, or if AOC is a straight angle and B is a point not on AC, then the measure of angle AOB plus the measure of angle BOC equals the measure of angle AOC. Well, let's draw a picture for this because it's kind of complicated. So I'm going to start off with this, be a point in the interior of AOC. Well, let's make an angle AOC first. So I'm just going to go ahead and draw a generic angle here. Okay, that's AOC. And I'm going to put a point in the interior. So that just means somewhere inside my angle. I'm going to label it B. Well, it looks like we're going to make that into an angle at some point. So I'm going to go ahead and put a ray through B. Well, looking at this, AOB, that's this angle right here, plus BOC, that's this angle right here, those have to add to angle AOC, the big angle, AOC. So that is in fact my part plus part equals whole, just like I had before. So let's look at two examples now. If measure of angle EAM, well, EAM in this guy right here, that's my whole, that's 87 degrees. And measure of angle EAF equals 62 degrees, that's this guy right here. Find the measure of angle FAM. So that's this one. I don't know what he is. Well, let's set this up. My part plus part equals whole. Well, my part, I've got measure of angle EAF plus other part, measure of angle FAM equals the whole measure of angle EAM. And we're going to plug things in. EAF was 62. I don't know FAM. And then that has to be at the end of the day equal to 87. So I subtract 62 to get that the measure of angle FAM is in fact 15 degrees. And that's my answer. So let's look at one last example here. Given that angle ABC is a straight angle, and guys, remember straight angles, that means it's going to equal 180 degrees, so that's a hint. Find the value of x in the measure of angle ABD and DBC. So we're again going to do part plus part equals whole. So my first part, measure of angle ABD, second part plus the measure of angle DBC is equal to the whole, the measure of angle ABC. And we did just say this is a straight angle, so this guy over here has to add to 180 degrees. Well, ABD is marked as being 11x minus 12 plus DBC is 2x plus 10. So part plus part equals 180. We're going to combine our like terms. I get 13x minus 2 equals 180, or 13x equals 182, or x equals 14. So we found the value of x, and now I want to find the measures of ABD and DBC. So my measure of angle ABD, they told me was 11x minus 12, so I simply plug in the 14. 11 times 14 minus 12 equals 142 degrees. And I want you guys now to find the measure of angle DBC. So go ahead and take a moment and do that. And you should have gotten 38 degrees. All right, guys, that's the end of this lesson. Go ahead and take a look at the MML work. Thank you guys very much.